Welcome to Simply Pi Maths.
In this video, we will learn how to write a sample space, the number of sample point n of s. So basically s and n of s, which we have learned in the previous video. We have to do the same over here. But along with that, we have to write event A, B, C. There will be some special events given to us. We'll have to identify what will come on these events. And once we identify these events, we have to find the number of elements in those events. Similar to that, like we say as n of s, right? So here we will say n of A, n of B, n of C. It is nothing else but the number of element in A, number of element in B, and number of element in C. So let's see a very simple example over here. It says one die is rolled. Okay, so first of all, after reading this first sentence, I should be able to understand what should be my sample space looking like. So I will start my solution like this. So I will say, since one die is rolled, since one die is rolled, let's give it a thought. What will happen when one die is rolled? What all possibilities are there? It can either show me 1 or 2 or 3 or 4 or 5 or 6, nothing other than that, right? So these are the only possibilities when a die is rolled. So that itself gave me the value of s. Now I need to find the value of n of s. So simply n of s is nothing else but how many elements are there? 6 elements. So I will write 6. So this we already knew. Now we have to do the same for event A. So what does event A says? Event A says event number on upper face. Okay, so let me just write it like this, A. Now what all can come inside A? So all the numbers which are even inside this, that is 2, 4 and 6. 2, 4 and 6. Simple as that. So this is n of A. N of A will be 3. There are 3 elements inside this, right? So it will be 3. Now taking the same for the other events also. So the next event is B. So let's see what is there in B. What does B says? So B says to give me odd number on the upper face. So which are the odd numbers out of these? 1, 3 and 5. 1, 3 and 5. So these are the list of odd numbers. So event B contains how many elements now? Again 3 elements. And finally the last one, event C. So what does event C says? Prime number on the upper face. So let me just write C and let me identify prime number out of these. So just a quick recap. What does prime number mean? Prime number is nothing else but the number which is not divisible by any other number. So basically the number which goes in their own table. So example is 2. 2 is a prime number. 3 is a prime number. 4 goes in 2's table, right? So this is not a prime number. 5 is a prime number. 6 goes in other table, right? 2's table, 3's table. So this is not a prime number. So and about 1. So 1 is neither prime nor composite. So this doesn't come under any of the category. So the only possibilities are 2, 3 and 5. So I will put it over here. 2, 3, 5. So n of C is how much? 3 elements. 3. It was a very simple sum, right? Let's see another example. So let's see this example now. It says 2 dice are rolled simultaneously. Same like the previous sum, but here this time we are throwing 2 dice simultaneously. Okay, so let's think like what does this mean? So if I put a die and I am throwing 2 dice this time. Okay, so I am throwing 2 dice at the same time. So what might have happened over here? The first one would have showed me 1 and the second one would have showed me something else, 2, right? Such a possibility is there, right? And there are n number of possibilities, or else it would have been something like this. The first one would have shown me 3 and the next one would have shown me 5, correct? So there are n number of possibilities with this event, like when I say 2 dice are rolled. So in order to make it simple, how should we write the sample space? So let's see. So I will say, first of all, since 2 dice are rolled, so look over here how the sample space looks like. So that means in sample space what I will have to write is, in the first die I could see 1 and in the second die also I could see 1. I will start with this pair. then I will say the first die it is 1 and in the second die it is 2. Okay, that means what? I am just keeping the first die value as constant, and along with that I am changing the second die's value. So 1 with 1, 1 with 2, 1 with 3, then similarly 1 with 4, 1 with 5 and 1 with 6. So once this is done, now what I will do is I will change the first die's value. So I will make it as 2 now, and 2 along with 1 of the second die, 2 along with 2 of the second die, 2 along with 3 of the second die, and I will follow this pattern. 3 and this should be 4, then 2 with 5 and 2 with 6. Now the thing to note over here is, like, once you are done with 6, right, don't start the next value like 3 over here. I suggest start the 3 comma 1 from here itself, so that while we are going forward with the other events, right, it will be easy for us to identify the pairs whatever is needed. So continue the same way, 3 comma 1 to 3 comma 6, then 4 comma 1 to 4 comma 6, 5 comma 1 to 5 comma 6, and finally 6 comma 1 to 6 comma 6. So that is the all possible values whenever we throw 2 dice. So here I have listed down all the possible values over here. Okay, so now what? Now it's time for n of s. So if you count all these things, there will be a pair of 36 values. So it will be 36, n of s will be 36. And now let's go to the event one by one. So the first event says, event A says, sum of the digits on the upper face is a multiple of 6. So what do you mean by multiple of 6? Multiple of 6 means it should go in 6 table. 6 table means what? 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, and this list will go on, right? Now what we have to think over here is, sum of the digits on the upper face is a multiple of 6. That means what? When we add these two things, if it comes to be a multiple of 6, then we have to consider this, or else we don't have to consider. 1 plus 1 is 2, right? It is not a multiple of 6. 1 plus 2 is 3, which is not a multiple of 6. So I need to directly hit for the values which will, the upper face values, adding which I will get 6, 12. Do you think 18 and 24 are possible at the first place? Because if you see, the maximum pair is 6 comma 6, and if I add these two things, what I will get? I will get 12. So 12 is the maximum possible value, isn't it? So that means there is no point where I can get 18 or 24 at the first place. So I just need to target the values which will give me 6 and the values which will give me 12 when they are added. So let me first target for 6. So just identify any one pair which will add and give me 6. 4 comma 2, isn't it? 4 comma 2, when I add 4 and 2, it will give me 6. Now if you catch hold of this, right, see, you will automatically get another pair. 5 comma 1, this will also give you 6. 3 comma 3, this will also give you 6. 4 comma 2, this will also give you 6. 5 comma 1, this will also give you 6. So this is the beauty of this pattern which we create over here. If you catch hold of one of the value, automatically you will get the remaining multiple values. So these are all the possible values which will give you 6. Okay, now I can also hunt for 12. So I believe 12 is achievable only for this value, right? 6 plus 6, 12. Other than that, there is no other pair which can give me 12. That means in event A, which we are talking about, right? Event A, in event A, I will have all these values, 1, 2, 3, 4, 5, and this one 6. So let me write event A over here, and let me start listing down all the values over here one by one. 1 comma 5, 2 comma 4, and I will start listing all these values. So once I have listed, it will look something like this. And let me just count the values, number of pairs in A. 1, 2, 3, 4, 5, 6. So there are 6 pairs. Okay, let's move on to the next event, event B. What does event B says? Sum of the digits on upper face is minimum 10. So what do you mean by minimum 10? Minimum 10 means it should be at least 10, right? That means a value greater than 10 will do. Yes, it will do, because minimum means at least it should be 10, not less than that. That means anything more than that is still fine. 10 is fine, 11 is fine, 12 is fine. Sum of the digits on the upper face. Okay, so if I, the same way, if I add the two numbers, it should give me 10, or it should give me 11, or it should give me 12. And I think looking out for 13 will not make sense, isn't it? Because maximum that we can get is 12, as we discussed earlier. So let me look for all these values, the values which will give me 10, the values which will add and give me 11, then the values which will add and give me 12. First of all, I will look for 10. 4 plus 6 will give me 10. If you see here, we have 5 plus 5 giving me 10, 6 plus 4 giving me 10. These are the values which will add and give me 10. And now the values which will add and give me 11 are this 2, 5 and 6, and 6 and 5. And the values which will add and give me 12 are just one value, 6 comma 6. That means these are the 1 2 3 4 5 6 possible pairs which will give me 10, 11 and 12. So minimum 10 means these three values I need to hunt for, and I can get it over here. So I will list it down in event B. So let me start listing it down, all these values over here in event B. So I will start with this 4 comma 6, and then I will go on with this and this, and hence I have all the values over here. Okay, so if I count them, they are giving me 6 values. So n of B will be 6. Okay, and let me move on to the very last event over here, event C. It says same digit on both upper faces. Same digit on both upper faces means what? Isn't it these values 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 and 6 comma 6? These are the pairs having same values on both the upper faces, isn't it? So finally let me write event C with all these values, which will contain 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 and finally 6 comma 6. So that means n of C will be 1 2 3 4 5 6. We have 6 pairs, so n of C will be 6. Simple as that. Let's see another example right there. So it says 3 coins are tossed simultaneously. So let me just first of all write, since 3 coins are tossed simultaneously, therefore sample space. So let's give it a thought, how will this look like? So when I say 3 coins are tossed simultaneously, so what does it mean? So I have 3 coins in front of me. The first one would show me head, the next one would show me head, and the third one would show me head. This is a very rare possibility. This can happen, right? All the 3s are showing me head. Or else it could be like, first is showing me head, the second one is showing me tail, and the third one is showing me head. So if we give it a thought, like there might be n number of possibilities over here. So let's see what pattern we should follow, okay, in order to make sure that we are not missing out anything while writing the sample space. So the pattern is simply like, first write 3 heads. That means all the heads are coming up on all the coins. Then what? In the last coin, change it to tail. Okay, then what, bring this tail over here in between. That means head, tail, head. Then bring this tail in the first position, so it will become tail, head, head. This is not the end, okay? So this is just the first line. Now we have to do the same thing with the tails. That means start with the tail in all the 3 coins. Then in the third position, replace the tail by head. Then bring this head over here in center, something like this. And finally bring this head in the first position, something like this. So finally you are there with all the possible combinations, and this will contain all the possible combinations. So we are making sure that we are not missing out anything. Okay. Now finally it's time to count the values 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 values or 8 elements in the sample space. Now let's look for the first event, event A. What does event A says? To get at least 2 heads. First of all, we'll have to understand this word, at least 2 heads. So understand, at least means minimum. Minimum means you should get at least 2 heads, means 1 head will not do. 2 head, okay, it's fine. What about 3 head? Is it fine? Yes, it is. Why? because it says at least 2 head, right? So at least 2 head means what? It should contain 2 or more heads. We are fine. It should not have less than 2 heads. That is what this at least word means. So let's hunt for all the possibilities where are 2 heads or more than that, 3 heads. So first of all, this is one of them having 3 heads. This contains 2 heads. This contains 2 heads. This contains 2 heads. Here there are not 2 or not 3. Here there is just one head, just one head, just one head. One head is not possible for this, right? So we will have only these values where there are 2 or more than 2, that is 3 heads. So I will just list down HHH, HHT, HTH, and finally THH. So how many elements do we have over here? We have 4 elements, isn't it? Okay. Now let's see the next event. Event B, it says get no head. Okay, to get no head. No head means what? There should be only tails, and the only possible combination is this, right? Where all of them are tails. Because in all the other possibilities there is at least one head or more than one head, right? So this is the only possibility where there is no head. So tail, tail, tail. So I will just close it like this and I will name it as n of b contains how many element? Just one element. And finally the last one, what does the last one says? To get head on the second coin. Second coin means the middle one. So this is one of the possibility where in the second coin we have head. Here also in the second coin we have head. Here we don't have head in the second coin, right? Here we have head in the second coin. Here we have head in the second coin. That is it. So these are only possibilities where head is coming up in the second coin. So let me write it over here in event C. So event C will have HHH, HHT, this one THH, and finally this one THT. So let me finally write the number of elements in this event C. 1, 2, 3, 4. So it is